So we would like to present our paper, leveraging artificial intelligence and big data analytics for operational optimization and clinical decision making in hospital setting. Systematic. Healthcare system worldwide, including those in Indonesia, are undergoing rapid transformation driven by dual pressure, operation demand, and limited resources. Hospitals face the challenge of providing high-quality patient-centered care while also controlling costs, optimizing workflow, and responding to an increasing complexity of disease. What is artificial intelligence? AI refers to the simulation of human intelligence machines that are programmed to monitor healthcare. AI support diagnosis, predictive analytics, and operational efficiency. We have methodology. There is inclusion and exclusion criteria. For inclusion criteria, we have the first one is a study published from 2020 until 2025. Second one is focused on AI or big data application. And the last one is empirical studies that prospective prospective or it is a non-hospital setting. Example community only or interpretation. The second one is a non-English language publication. And the last one is editorial opinion only disease. Initial research written for the 1,286 records after duplicate and title abstract screening. 35 students met equation and were extracted for the data or authorship, year, functionality, AI big data, method, domain, study design, and primary outcome. Okay. And then what is the workflow? It's scheduling, forecasting, optimization, flow management, of course, emergency department, and intensive care unit. Administrative process is including billing, discharge documentation, and claim management, reduce clerical workload, and minimal processing unit. And then clinical decision making. Machine learning models outperform traditional scoring. Systematic in early detection of diseases, cardiovascular disease, and cancer, with report improvement in diagnosis accuracy of 8 until 10%. AI-based clinical decision support system have increasing demonstrate potential to augment patient decision making by integrating large-scale datasets. Financial performance and fraud detection. Predictive analytics identify anomalies in billing data and fraudulent claims, saving hospital millions of dollars annually. So AI-enabled coding and billing system improve claim accuracy, shorten reimbursement cycle, and also reduce revenue leakage. Optimize hospital cost structure and revenue cycle management. And also fraud detection in healthcare capable of distinguish between legitimate and fraudulent submission with high sensitivity and specificity. After that, data governance and ethical considerations. Each study emphasizes ethical and governance aspect of AI adoption. Commonly cited issue. There is three. The first one is the lack of explainability predictive model, and the second one is the representative of training data sets. Last one is governance framework for AI in health care remain under development. Yeah, we have reached our discussion. This systematic review consolidation evidence from 35 empirical study on the role of artificial intelligence and big data analytics in hospital management. The synthesis showed a clear trajectory, while early AI applications focus primarily on diagnosis and imaging, and also predictive models. Recent study revealed diversification into workflow optimization, financial management, and ethical governance. Interpretation of finding that is four. First one is workflow optimization consistently emerges as the most quantifiable success story. The second one is clinical decision making represent the most studied domain. The third one is the financial and fraud detection application remain under explored compared to clinical decision support, yet their potential is substantial. The last one is finally the data governance and ethics represent the most under development, yet urgent. Comparison with prior literature, this review find a marked shift toward real-world implementation. Several studies report live development of AI tools in emergency department, operating rooms, and radiology units. Black box problem highlighted by Obermeier, Obermeier and Emmanuel Schwann 2016 remain unresolved as most AI system lack of explainability features. So we have research gap and limitation. The synthesis identifies several critical gaps, conceptual imbalance, and short evaluation horizon. After that is governance framework. The fourth one is the interoperability challenge. The last one is limited patient-centered outcomes. Practical and policy implication. For hospital administration, AI is a practical asset, improving efficiency and outcomes. For the technical capacity, investment in robust data infrastructure, in operability, and cybersecurity. For the human resource, training clinicians and administration to interpret and apply AI, governance, accountability, explainability, and fairness, concept and ethical use. For financial sustainability, AI as a tool for fraud detection, revenue cycle management, and cost alignment. And the last one is policy makers for the urgency of regulatory clarity. For the future direction, is conduct multi-center trial sustainability of AI integration. Then focusing of affordability, local workforce capacity, and infrastructure readiness. Advanced explainable AI to improve clinical trust and accountability, incorporate patient-centered metrics, trust, certification, health equity, and operational financial outcomes. The last one is develop global governance frameworks for the ethical AI. Conclusion, the systematic review of the 55 clinical study from 2020 until 2025 demonstrate that artificial intelligence and big data analytics are rapidly shaping hospital operation and clinical decisions. Overall, the findings suggest that AI and big data will transform potential efficient, cost-effective, and patient-centered health care system. So,